In this lesson, we're going to look at systems of equations, but with three variables this time. We can use a few of the similar methods that we did with two variables. So we're going to start out with some substitution. One method is when we can use this back substitution method, and it's nice when it's set up this way, but we try to look for something that's kind of like a triangular equation setup. So we've got all the x's, y's, z's, all of the variables on the left and anything that's constant on the right. But what we see in one of the equations is that it's only down to one variable. So if 5z equals 15, then I can solve for z. So I can take that 5z equals 15, divide by 5 and get 3. So z equals 3. We're going to back substitute to solve for y because this has only two variables, y's and z's. So 10y minus 3z, well, z we just found to be 3, equals 11. 10y minus 9 equals 11, which means 10y equals 20 if we move the 9 over, and divide by 10 gives me 2. So now y equals 2, and we're going to substitute that y and the z into our top equation to find x. So 4x plus 4 times y, which is 2, minus z, which is 3, equals 0. 4x plus 8 minus 3 equals 0. And we just simplify 4x plus 5 equals 0, subtract our 5 gives me negative 5, and I divide. So negative 5/4 would be x. We found all three variables using that method, and then we just write it out as our point. But this point has three parts. So it's negative 5/4 for x, then y is 2, then z is 3. So go ahead and pause and try number 2 that same way. If you did already, you divided by 3 and got c equals negative 2. Then you can plug that into the other one, so negative 4b plus 4 times c, which was negative 2, equals 16. Negative 4b minus 8 equals 16. We add 8 to get negative 4b equals 24. And then divide by negative 4 makes b negative 6. Substitute both of those in, so 6a minus 3 times b, which is negative 6, plus 6 times c, which was negative 2, equals negative 24. 6a plus 18 minus 12 equals negative 24. If I combine like terms on the left side, we get a positive 6. And then we subtract 6 to get negative 30. Divide by 6 gives me negative 5. Using all three parts, we found a point of negative 5, negative 6, negative 2. All right. One of the other methods is elimination. This takes a little bit longer to do, but what we want to do is we want to get this 3 by 3 system down to a 2 by 2. So a 3 by 3 means that we have three equations with three variables, and we want to eliminate this down into two equations with two variables. So I'm going to pick one of the variables that looks like it could be easily manipulated. And I can see that z could be easily manipulated so that I can eliminate them. So what I'm going to do is just pin the first equation, negative 2x minus 2y plus 2z equals 12. And I use that against the last equation, negative 4x minus 6y minus z equals 5. I do that so that when we multiply the bottom one by 2, what it's going to do is eliminate the z's. So that top one stays the same. Negative 8x, negative 12y, and negative 2z equals 10. When we add this together, our z's eliminate, and we have an equation. Add that together gives me negative 10x minus 14y equals 22. So that didn't solve for a variable yet, but it's getting us closer. So I picked, let's just label these. These are 1, 2, and 3. I picked equation 1 and 3. I'm going to pick equation 2 and 3 now. So let's say I picked 2 and 3. That's 2x minus 3y plus 5z equals negative 1. Negative 4x minus 6y minus z equals 5. We did that so that we can manipulate the bottom one. And I'm going to multiply it by positive 5. So this still says 2x minus 3y plus 5z equals negative 1. Top one didn't change, but the bottom one's now negative 20x. 5 times negative 6, negative 30y. And 5 times negative z is negative 5z equals 25. We add straight down and the z's finally cancel out. So negative 20 and 2 is going to be negative 18x, negative 33y equals 24. I did all of that so that we can eliminate with this 2 by 2 system. So this has created a new system. Let me just rewrite this in a different color here. Negative 10x minus 14y equals 22. And negative 18x minus 33y equals 24. That's something that we have seen before because it's now a 2 by 2, but it will take some manipulation as well. So if I want to eliminate, I can pick either x's or y's to eliminate, but neither one of them is going to eliminate easily. So let's think about what we could multiply by so that we could get it to eliminate. I'm going to take the top one and multiply by 18, and the bottom one and multiply by 10. Now, I notice I chose negative 18 and not a positive 18, because if I want these to eliminate, I need them to be opposite signs. So one of them will have to be a positive, one will have to be a negative. All right, I'm kind of running out of room, but this would end up being, let's move this down. Negative 18 times negative 10 makes that positive 180x. Negative 18 times negative 14. We'll have to use the calculator for that. It's 252. And then negative 18 times 22 is negative 396. Then we multiply the bottom one by 10, so negative 180. 10 times negative 33 is negative 330y. And 10 times 24 is 240. So I could have probably picked a value that was different than 18 and 10 and still gotten the x's to eliminate, but I knew that was going to be a quick, easy way to do it. So when I add straight down, 252 plus negative 330 is negative 78y equal to negative 396 plus 240, negative 156, and then we divide. So negative 156 divided by negative 78 is positive 2. We did all that work to find out what y is, but we still need to plug it back into one of these equations to get x. And you don't want to go back to the original because those have x's, y's, and z's. So I just plug it into one of them. Let's say I have 180x plus 252 times y, which was 2, equals negative 396. 180x 252 times 2 is 504. Negative 396. And we're subtracting this 504. So negative 396 minus 504 is negative 900. When I divide that by 180, we got negative 5. So now we have x, y. The only thing left to solve for is z, and you can plug that into any one of the original equations. Let's plug it back into the first one. Now let's go back to, we'll say equation 1. Negative 2x was negative 5 minus 2 times y, which was 2, plus 2z equals 12. I'm kind of running out of room here, but negative times negative makes that positive 10, minus 4 plus 2z equals 12. So 6 plus 2z equals 12. Subtract your 6, gives me 6, and divide by 2 gives me 3. So working all that out, we finally got it down to our 3 variables, and we just write our solution out in order. So x is negative 5, y is 2, and z is 3. Those definitely take up a lot more space when you're doing them. So try number 2 at that point. Again, you can pick any of the equations to eliminate down and get it to a 2 by 2. All right, what I'm going to do is take the first one and use it against the second one. I think the hardest thing about this is that you have s's that sometimes look like 5s when you write them, so be careful with your handwriting. So I'm going to multiply the first one by negative 3. That turns this into negative 3r minus 3s minus 15t, and then negative 18 times 3 is going to be 54. We multiply, or this bottom one we don't have to multiply at all. So when you add that straight down, the r's are what cancel out this time. Gives us a 3s negative 15 plus 6, negative 9t, and then 54 minus 6 is going to be 48. So we have a system that looks like this down to 2 variables. We still need to get the other ones down to 2 variables, so let's take that first and last one together. So r plus s plus 5t equals negative 18, and 6r minus 5s minus 3t equals negative 20. I'm going to multiply the top one by negative 6. So negative 6r negative 6s, negative 30t, and then 18 times 6 is 108. The bottom is 6r minus 5s minus 3t equals negative 20. We add straight down, the r's are what cancel out. So that gives me negative 11s, negative 30, and negative 3 is negative 33t. And 108 minus 20 is going to be 88. So we have s's and t's, s's and t's. I can put those two equations together to give me 3s minus 9t equals 48, and negative 11s minus 33t equals 88. We are trying to eliminate one of the variables. We're going to have to multiply both of them. So let's say I multiply the top one by 11 and the bottom one by 3. That would get rid of the s's. All right, so this becomes, I'll still run out of room a little bit, but 33s. 11 times 9 is going to be negative 99t, and then 11 times 48. It's 528. I get negative 33s. 3 times negative 33 is going to be negative 99t. And 3 times 88 is 264. Add straight down. When I add, I get 33 and negative 33, which is 0. But this is not 0. Negative 99 and negative 99, you're adding those together. Negative 99 plus a negative 99 is negative 198t. And 528 plus 264 is 792. We're dividing by negative 198. So I'm going to take that answer divided by negative 198. So t is negative 4. Now that I know t, we can take that and substitute it into one of the equations that just has two variables. You don't want to plug it back into the original. So pick one of them. I'm just going to choose this 3s minus 9t equation. So let's mark this over here. 3s minus 9t. T is negative 4 equals 48. Plus 36 equals 48. We subtract 36 to get 12 and divide by 3 to get 4. So s is 4. The last thing we want to do is plug both of those in, t and s, into one of the originals. It doesn't matter which one, but if I do it in the first one, I don't have to divide by anything for r. So we just have r plus s, which is 4, plus 5 times t, which is negative 4, equals negative 18. So r plus 4 minus 20 equals negative 18. R minus 16 equals negative 18. And then we add 16 over to get negative 2 still. We put them in order as we write out our answer. So I would say negative 2, r, s, t, s would be 4, t is negative 4. And to check to see if this works, if you want to actually check your answer, all you have to do is take it and plug it back into your equation. So r was negative 2 plus s, which was 4, plus 5 times t, negative 4, should equal negative 18. And it does. You could do that for all three of them and see that it still works for all three. All right, we still want to see an infinitely many solution example. So in this one, I've got x, y, z, x, y, and no z, x, y, z. So really, I want to get down to where we have no z's. All right. So let's take the first and last one, put them together. 3x minus y plus 2z equals 6. X plus 3y plus 2z equals 22. We're trying to eliminate the z's since this was x's and y's already. I'm just going to multiply the bottom one by negative 1. So that would be 3x minus y plus 2z equals 6, and negative x, negative 3y, negative 2z, and negative 22. Add straight down, the z's are going to cancel out. I get a 2x minus 4y equals, and then 22 minus 6 is negative 16. So negative 22 plus 6 is negative 16. This equation's down to x's and y's. We already had one that was x's and y's, so that's why I wanted to get just those two variables together. Now we can set that up. 2x minus 4y equals negative 16. We pin that up against the second equation, which was negative 2x plus 4y equals 16. Sorry, there we go. If I add straight down, what we see is the x's cancel out, but so do the y's. And really, the last ones do too, so I get down to 0 equals 0. And if you remember from our two variable systems, that meant that there were infinitely many solutions. We had to take our answer and solve for the variables. So in a 2x2, two variable system, we only had x's and y's, and we let y be y and solve x in terms of y. This one's a little bit different. So we have three variables, and we're going to have where x is some kind of expression in terms of z's. Y is some type of expression in terms of z's, and z is just going to be z. We write that as an ordered pair. So if z is just z, I want to take this expression and solve it out. So let's do it in a different color. 3x minus y plus 2z equals 6. The only way for me to get this y in terms of z is to eliminate our x's. So I actually have to do some more work again. And you may not have had to do this if we had chosen to eliminate one of the other variables first, but let's multiply this by negative 3. So now I have 3x minus y plus 2z equals x. Negative 3x minus 9y minus 6z equals negative 66. If I add straight down, my x's cancel out, and now I have negative 10y, 2z, and negative 6z is negative 4z. Negative 66 plus 6 is negative 60. I have an expression that's just y's and z's. That's what we needed if we want to get y in terms of z. So I want to take this and solve for y. So negative 10y minus 4z equals negative 60. I'm just rewriting it to give me some more room. Negative 10y equals, add your 4z over, and then divide by 10, negative 10. So 4 divided by negative 10, if you want to do that in the calculator, you can. But turn that back into a fraction, so negative 2/5. And then 60, negative 60 divided by negative 10 is positive 6. So y is in terms of z's now. But we also need an x in terms of y expression. Sorry, an x in terms of z. So if I do that, I want to do this same thing again, but try to eliminate our y's. So let's do this over here to give me 3x minus y plus 2z equals 6. We had x plus 3y plus 2z equals 22. We multiply the top one by 3, and that will get rid of our 3y's. So I get here 9x minus 3y plus 6z equals 18. On bottom, we already had an x plus a 3y plus 2z equals 22. If we add straight down, our y's are gone, and I have 10x plus 8y, sorry, 8z, not 8y, equals 40. This expression is x's and z's, so I can solve for x so it is in terms of z. Divide by 10 gives me negative 4/5 z plus 4. It says that our final answer should be written in the following way, where we have x's in terms of z's, y's in terms of z's, and z is just any real number z. So if I write this out as a point, I'd have negative 4/5 z plus 4. There's our x part. Our y part is negative 2/5 z plus 6. And then z is just z. So I know that one was definitely harder, but you want to try to practice a few of these that have that infinitely many solutions type.